Good afternoon, everyone. My name is Pham, and today I'm going to talking about screen to words and automatic mobile UI summarization with multimodal learning. And the conductor of this research is Bryan Wang with his colleague at Google Research when he was an intern at Google research team. And so I'm going to talking about the abstract of the project, which we learn about motivations, the approach, and the goal of this project. And yes, of course, we're talking about the proposed solutions and evaluations of this result. And we are talking about potential applications of the screen to word as well as the future directions of this screen to word. And yes, we're going to have a summary of this paper. So what is mobile UI summarization? Yes, this is a summary of what is on the screen. And why do we need to do that? Because nowadays, like, there's a lot of mobile app which is have a lot of diverse UI layouts and not really have a uniform or anything. So it's better to using a summarization tool to better understand and capture essential content of and functionalities of the screen. And yes, it's going to be useful for many language-based application and scenario. So the approach of this to this problem is using deep learning to handle large-scale complex data sets, which are UI screen source, including text, image, UI schematics, and so on. And the goal of this project, of course, is to build a model that ultimately encapsulates essential information of the UI screen into a coherent language phrase. So on the screens now is like an overview of the whole process. So first they're going to take more than 22,000 UI screenshots along with more than 112 human annotations, going through data analysis process to create symbol summary. And that those summaries will go through summary focus area to extract more keywords and important information. And from there, can say that we have draw screen summary. And using those screen summary, we're gonna build the model, which is mobile UI summarization tool. So the analyzes UI screenshot include together with view hierarchy, JSON file, and app directions from the App Store. We're gonna go through deep neural network to create screen summary, which is more natural to human language. So the first step, data collections, I mentioned they took more than 22,000 screenshots from 6,269 intro apps, with more than 112,000 human annotated English summarizations. And each screen comes with a screen source and a view hierarchy JSON files and the data annotations made by 85 professional laborers. And throughout the annotation step, they're going to have a guideline for the laborers for do and for don't. So in general, do keep it short 5 to 10 and focus on most important info only. And using the structures non-clause to build your summary. And as well, use the text to help you build it. And don't just focus on a small, to focus on a whole screen, and don't be biased, don't give you opinion, just give out a fact, and don't describe by color textures, but just also including the category of the app and avoid using the name of the app. And the next step is data analysis. So each screen will have 5 summary annotations, and and after that, we're gonna go to remove the unessential words in general. So we're gonna have 7 words, and in each summary, we would count each word and compare it with 4 other summaries so that we can decide if it's like true positive. That means really appear in everywhere and not all. And then after that, we're gonna pick out like 4,500 words uh, to a summary focus area so that we can figure out the best and most essential word. Now, typically, it's like more than 60% of the whole screen. So this summary focus area just to evaluate the summary and their perceived important info. And then with all the analyzed data, we're going to use it to build the model. So as mentioned earlier, so the UI screen sort will be cut down to 64 by 64 more screens and using extracting now the info. And those small elements will go through CNN and get out with the screen summary. And at the same time, the input data will with the app description and view hierarchy JSON file will go through embedding encoders to generate also screen summary. And then together with both results, screen summaries will go to decoder and the transformer decoder will create the screen summary for the screen. So in order to build his applications, he built different 5 different model. And the first one, Big Cell is only using image analyzed on CNN, and the layout only using the result from a JSON file. And Big Cell and layout will be the combination of those two. And Big Cell layout and text is using the previous model with the textual information according from the screen text. And lastly, the full model will include app descriptions, which is they use to build all of the information. So this is the result. So you can see that these are the 7 columns is 7 different evaluation metrics, and the models is the last 5 is his model, and the last one is a full model, which is best result after all. And there's like he mentioned about 3 potential applications of this string to word. First is language-based user interface retrieval. So basically, it's really helpful to give better, like more detailed research bar suggestions, like side page for social media instead of simply side page, which is more typical for keyword-based user interface retrieval. And then, yes, with a better summary, it will have visually impaired user when you're using an app. And scheme indexing conversational mobile applications with this summary, along with app descriptions, is going to be indexing to the mobile, and the user can actually just simply say create email in Gmail, and then the application will pop up. And so this is next we're gonna review it. So he admitted like 3 limitations of string word, the inaccuracy, so some images got misinterpreted and give, of course, wrong summary, and missing a lot of apps, missing like app description. So it's also hard to actually give the accurate summary. And general summarization, what is that? The project only added only saying what is going on the screen, nothing instead of like saying to what to do on the screen. And yes, so because of these limitations, the future work can use this and to create a better user interface design. And for my opinion, it's really good, practical, and feasible idea to use for designing better user-friendly UI and UX for a mobile app. And I hope it can be adapted by our friend like Apple for more friendly Siri. So on the screen, this is like the result of the outcome. So 3 of them, like they're accurate except for the baby at the below here. It's kind of out of like kind of failure of the model, but overall it's really good. So in summary, this is a deep learning approach to build an automated tool to generate a sustained summary of a mobile application screen. And using deep neural network, we can bring better and more concise summarization and understanding of UI screen. This is an open source project. You can find it on GitHub. Thank you for listening, and this is a Q&A time.